In this video, I want to solve the equation 7 times x to the 2/3 power equals 28. So when you're solving an equation like this that involves a rational exponent, the first thing to do is to isolate that most complicated part of this equation, which is the x to the 2/3. We want to get that part of the equation by itself. So I'm going to divide both sides of this equation by 7. And so that gives me x to the 2/3 equals, so conveniently enough, 28 is evenly divisible by 7. We get 4 here. Now, in order to get the x by itself, I want to get rid of that exponent. Keep in mind this property of exponents, so x to the a raised to the b is x to the a times b. If my goal is to end up with x to the first, and I have x to the 2/3, then I want to raise it to a power so that when I multiply those exponents, I get 1. In other words, I need to raise it to the reciprocal power, which in this case will be 3/2. And notice that when I do that, I'll have x to the 6/6, which is x to the first. So that's the way to attack this one, is you raise it to the reciprocal exponent. So I see 2/3, I'm going to raise it to the 3/2 power, which is fine as long as I do that to both sides. Now here's where things get a little bit tricky, so you have to pay close attention. Two things to point out here. So we are taking a square root. We're solving by taking a square root, which means we need a plus or minus. Remember that when you solve an equation like x squared equals 4 by taking the square root of both sides, you need to note that there are two numbers that you can square to get 4, and it's plus or minus 2. Okay, so when we do this, we are going to need to insert that plus or minus in front. If you solve by taking an even root, so in other words, if the number in the denominator here is even, then we need the plus or minus. Also, and actually, hold on, let me label. So we have an even root, so we need that plus or minus in front. We have an odd power, so we're solving by taking this expression to an odd power, the third power. So we will not get extraneous solutions. When you solve an equation by raising both sides to an even power, that's when you get those extraneous solutions. So because the numerator is odd, we don't need to worry about checking in the end for extraneous solutions. That's not going to happen. The extraneous solutions sneak in when you raise both sides to an even power. And the way that happens, by the way, I mean, if you think about the equation x equals 2, has only one solution, right? Only one number in the solution set is 2. When you square both sides, or raise to really any even power, these extra solutions sneak in. The -2 sneaks in where it didn't satisfy the original equation. So that's why we have to worry about that with even powers. These extra solutions sneak in. That doesn't happen when we raise both sides to an odd power. Okay. So I can note at this point that number on top is odd. Don't have to check for extraneous solutions. Number on the bottom is even, so I need a plus or minus in front. I'm going to get two solutions potentially here. So plus or minus 4 to the 3/2. I'll write it that way. Now, rational exponents like this 3/2 power, we read that as power over root. So 4 to the 3/2 power, another way to write that is the square root, it's the second root, so square root of 4, so I almost went ahead and wrote the 2 underneath, square root of 4 raised to the third power. So that's 2 raised to the third power, which is 8. So our solution set in this case is -8 and +8. Both of those values will satisfy this equation because, and you don't have to check, I don't require that you guys check, but let me just point out, just to demonstrate, because the method here I know is a bit tricky. If x equals 8, we want to verify that this works. 7 times 8 to the 2/3 power would be 7 times power over root. So this is the cube root of 8 squared. Cube root of 8 is 2, and when you square it, you get 4. So we do get 28. If x was equal to -8, we would have 7 times -8 to the 2/3 power. That's 7 times the cube root of -8 squared. And that's 7 times -2 squared, which would still be 7 times 4. So we still get, 7 times 4. So we still get 28. So we're in good shape on that one too. So you don't have to check your answers with these. I mean, because I pointed out we won't have extraneous solutions. We know that. But just to show, what's going on overall with this problem, because I know the fractions in the exponent can be tricky. I wanted to show you how you can check the answers. But this is your method. So you raise it to the reciprocal power, in this case 3/2. Interpret that as power over root. So this is the square root raised to the 3rd power. Evaluate that, and we were done here.